let's check out this question. So suppose that A, B, and C are collinear points. That means that all 3 points lie on the same straight line. And we're given that B is between A and C. And we're also given the following lengths, that AC, that length of that line segment is 25, and BC equals 7.2. And the question is, what is AB? So first thing I think we should do is try to draw a picture of the situation. So we know that B is between A and C. So we have some line segment. And on one end we have A, and the other end we have C, and B is somewhere in between. I don't know where. I'll put it right over here. Now, what else do we know? Well, we know that the length of AC, so that entire line segment, equals 25. That's given. And it's also given that the length of the line segment BC is 7.2. So I'll write that as BC has length 7.2. Now, the question is, what is the length of the line segment AB? Well, now we're going to use this great postulate that says that if you want to find the length of the line AB, you know that length, and add it to the length BC, then in fact that's always going to yield the total length AC when all the points reside on the same line. So, armed with that result, I can now insert all this data. So let's see. AB, that's the thing I want, so I just better keep that there. Plus BC. Well, BC we know has length 7.2, and that equals the length of the segment AC, which is 25. So now I want to solve for AB. How do I do that? Well, I want to undo the addition of the 7.2, so I subtract 7.2 from both sides to keep these balanced equation. And when I combined, I see 7.2 minus 7.2 is 0, so I'm just left with the length of the segment AB here. And then I have 25 minus 7.2, and I see 17.8. So the length of this segment right here, we just found to be 17.8. Neat. Okay, now let's take a look at another example where we can see this result being used in practice. So here's a line segment, PQ. And we'll notice there's a point R in between. And we know that this length right here, PR, is 19. And we know that RQ has length 6x minus 1, although we don't know what x is. However, that x also has the property that 9 times x represents the length of the entire segment PQ. Our mission is to figure out what is the length of the entire line segment PQ. How can we do it? Well, we can use the postulate we just talked about, namely that the whole is equal to the sum of its parts. So this length is actually equal to that length plus that length. If I use that, I can write down now an equation. This entire length, 9x, actually equals this length, 19, plus this length, 6x minus 1. Now I can clean up this equation a little teeny bit and write it as 9x equals 19 minus 1 is 18 plus 6x. Now what I'd like to do is solve for x. So the first thing I'll do is I will balance this equation but try to put the x all over here. So I'm going to subtract 6x from this side and 6x from this side. And when I do that, what do I see? Well, what I see here is here I have 9 x's and I subtract 6 x's, so I'm left with 3 x's. And here the 6x minus 6x cancels, I'm just left with the 18. If I now divide both sides by 3 to undo the multiplication of 3 in front of the x, what I see is x equals 6. Now you might say, hey, that's the answer, x equals 6 and we're done. But always make sure we understand what we're supposed to actually do. Our mission wasn't to find x, it was to find the length of PQ. The length of PQ is actually 9 times x, so the length PQ is equal to 9 times 6, which is 54. So that's the length we were trying to find, and we just used the x equals 6 to get us there. Fun.